Polynomial functions assignment by Katie Field. So the first question we have is 2x cubed minus 10x squared minus 16x plus 24. So what do we know? First, we know that it has a positive leading coefficient. The coefficient defines the direction of the end's behavior. In this case, the positive 2 leading coefficient tells us that as x goes to infinity, y goes to infinity. We also know the degree of the polynomial, which is, in this case, degree 3. The degree of the polynomial defines whether the y values end in the same direction or opposite directions. In this case, the odd degree 3 means that they will be in opposite directions. So, as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to negative infinity. And finally, we know it has a y-intercept of 24. The y-intercept is where the x-axis, the polynomial, will cross. In this case, it will cross at positive 24. So now we must solve and factor the polynomial. So to do this, we must start with the remainder theorem. So we input a number into the equation for x. If it equals 0, then we know that the opposite number is a 0 within the equation, or a factor. So we first try and put a -1 into the equation for x, and we find that it's equal to 28. So this tells us that x plus 2 cannot be factored perfectly into the equation. So we try it again, and we find that x equal to -2 is equal to 0. And since it is equal to 0, we know that x plus 2 is a factor. And so we have our first factor within the factoring of the equation. So we take that factor and we long divide. So we divide by putting the factor that we found and dividing it using long division into the equation. So we divide it through, we put it in, and we find that 2x squared minus 14x plus 12 is what we have left when it is equal to 0. So from that, we find that g of x is equal to x plus 2, 2x squared minus 14x plus 12. So from here, we can do simple factoring of the 2x squared minus 14x plus 12. So we find that the 2 times 12 equals 24. And we also know that the b value must equal -14. So -12 times -2 is equal to 24, and -12 plus -2 is equal to -14. So we put them in, and we find that the other factors of the equation are 2x minus 2 and x minus 6. So our final factor form is 2x minus 2, x minus 6, and x plus 2 are our zeros on the graph. And then, so we're going to imagine that this is what we originally saw before we knew the actual equation. And from this, we can tell the zeros. So we know that it has a 0 at -2. It has a 0 at 1 and a 0 at 6. So in this, it would be x minus 6 would be a 0. We know that x minus 1 would be a 0, and x plus 2 would also be a 0. We also can figure out the turning points on the graph through the top and the bottom points. So it has 2 turning points on this graph, and you can sort of guess that they're around 30 and around just above 70 from the graph. You also know that all of the zeros are order 1 because they go straight through the x-axis. We also know that it is an odd degree polynomial because one of the y values goes down and the other goes up. So, question number 2. We have negative 3x to the 4 minus 4x cubed plus 14x squared minus 4x minus 3. So once again, we can find out that it has a negative leading coefficient. It's an even degree polynomial this time, and has a y-intercept of y equals negative 3. So we know that the graph will cross negative 3 on the y-axis, that it will have the end behavior as x goes to infinity, y will go to negative infinity. And an even degree means that both of the end behaviors will end up in the same direction. So now we use the remainder rule to find the 0, long divide to factor 5 once again. So first we use the remainder theorem and we input negative 1 into the equation, and we find that it's equal to 16. So it is not perfectly factorable. So we try again with negative 3, and we find that it's equal to 0. So we know that x plus 3 is a factor of the equation. Now we long divide. So we put divide x plus 3 into the equation, and we find that negative 3x cubed plus 5x squared minus 1x minus 1 is what we are left with. So now we repeat again using the remainder theorem, and we find that when you put 1 into the equation, it's equal to 0. So x minus 1 is a 0. So we long divide, and we find that negative 3x squared plus 2x plus 1 is what remains. So we factor that, and we find that negative 3x plus 1 and x minus 1 are factors of the equation. So our result is negative 3x plus 1, x plus 3, and x minus 1 squared are the factors. So now looking at the graph, we can see that it crosses the x-axis 3 times. 2 times you can tell that it's an order 1 because it goes straight through the x-axis. And we can tell that there's an order 2 because it turns at x equal to 1. We also know that it has 3 turning points, and that it crosses around negative 1 or 2 for the y-intercept. So finally, we're going to look at question number 3. Question 3, we are given the factors of an equation, and we are going to try and graph it. So from what they are given to us, we find that we have an order 3, an order 2, and an order 1. So with the order 3, we know there will be an S-bend. At order 2, there will be a turn. And with the order 1, we know that it will go straight through the x-axis. The other thing that we need to figure out for this equation is the x-intercept. So we put in 0 for x, and we find that the x-intercept is 18. So from this information, we can graph the function, or the polynomial. And so, first, we know that it crosses at positive 18. So that's our first move. Then, we also need to make sure that it crosses the x-axis 3 times. So first, we look at x minus 1. So, at x plus 1 on the graph, we do an S-bend turn. Then we go back, and we see x minus 3 is a degree in order 2. So at 3, which the graph is a little bit off, but it doesn't turn. And finally, we look back to last time, and we find here if you actually calculate it out and you put x equal to 0, that at x plus 1, it will, or x minus 1, it will go, because it's order 1, it will go straight through the x-axis. And therefore, we have a graph, approximately. It's not perfect. And then, that is the end of the presentation. That 3 different polynomials. First was a cubic function, and we learned the basics of you have to use the remainder theorem, long dividing, and factoring to find the factors of the equation. Then we expanded this knowledge by using a quartic function and just developing those skills. And finally, we took a factored polynomial and learned how to graph it. So we should know how to use the remainder theorem, how to find an x-axis, how to find factors, how to long divide. We also need to know how to find a y-intercept and different orders and what we can find from a function, such as the leading coefficient, what degree it is, and such forth. So thank you for listening.